Greetings, everyone, from my hometown of Chicago, Illinois, where I'm spending some much needed time with family and friends as we head into fall. I'm excited to bring you this month's Math Fix task, so without further ado, let's get started.
Today's Math Fix is brought to you by S.ID.3, which asks students to interpret differences in shape, center, and spread in the context of different datasets, accounting for possible effects of extreme data points. Let's take a look at today's problem. Students are asked to come up with several different seating charts for an event where the only information they know is that 8 people have RSVP'd to attend, and the mean age of the attendees is also 8. Where might students start with this? Let's jump in. Some students might realize that perhaps the simplest solution is one in which every attendee is 8 years old, since the mean of a dataset with all 8s must be 8. This could be a 3rd grade class party, for example. But how might they proceed from there? Some students might use a balancing or pairing approach and realize that as long as they have pairs of numbers that add to 8, the mean will also be 8. They might work outwards from 8 to create a list of ages that is something like 8 and 8, 7 and 9, 6 and 10, and 5 and 11. They might create a seating chart where the younger children are at one table and the older children at another, and the two 8-year-olds are together. The context here could be a family function with a group of cousins that range in age from 5 to 11. Another approach to finding a possible set of ages could be to realize that, by the nature of calculating mean, the 8 numbers must add up to 64. From here, they could work backwards and randomly subtract numbers from 64 until they get 8 numbers. Depending on the numbers, various seating charts and contexts may arise. There are many extensions for this problem in addition to creating a context. We could ask students to create graphs of their data sets and describe the different shapes and distributions. Depending on the set, we could get shapes that look like a normal curve, a U-shaped distribution, a uniform, or a skewed distribution. Additionally, we could ask students to look at other measures of center for their graphs and see if a different measure might better describe their data. For example, a data set with 4 1-year-olds and 4 15-year-olds is probably best described by the two modes and not the mean or median. Perhaps this is a group of teenagers with the children they babysit? Another interesting extension could be to figure out the age of the oldest possible attendee at the event. Could we have a 70-year-old at this event? We know that the ages must only total to 64, so this is impossible. If we are dealing only with whole number ages, then the oldest person could be 57 with 7 1-year-olds, perhaps a grandparent with septuplets. Finally, you could ask students to change the parameters. Perhaps there are more than 8 attendees, or a different mean. Perhaps the numbers no longer represent ages. What else could they represent? The possibilities are nearly endless.
And that's this month's Math Fix task. We know there are lots of different ways that you can adapt this problem for your students, and we look forward to hearing about those ways. Don't hesitate to share with us your take on our October Math Fix problem. Until next time.